Multiplicative relationships. Okay. Multiplicative means you're either multiplying or dividing. So we're finding the relationships in these tables between the x value and the y value. So what I notice in my first table is my input is 0 and my output is also 0. So 0, sorry, I need a pen. 0 to 0, then 1 to 12, 2 to 24, and 3 to 36. And it gives me the rule down here. What I'm doing to all of the x's is I'm multiplying them by 12s to get to the y. So when we ask you what is the rule, that's just asking what do I do to the x to get to the y. Okay, so then let me scroll down a little bit. Now what would that equation look like? Well, that is just simply putting x and y into an equation. Usually they start with a y equals, and then what I'm doing is I'm taking all the x's times 12, so the way algebra will show that is a 12x. Remember, when a number is next to a letter, that means it's multiplying. So whatever the x is, times it by 12. Now I'm going to transfer that information onto the graph. So here's my x down here. If my x is 1, what is 1 for the x times 12? 12. And my coordinates would be 1 and 12. And then I put a 2 in place of the x. What is 2 times 12? 24. You put a dot there. And then 3 times 12 is 36. So that's a graph representation. So we have a table representation, we have an equation representation, and a graph representation. Multiple representations. Okay, so let's think of a scenario where something, one of this has 12 of these, 2 would have 24, 3 would have 36. I'm thinking maybe cases of like Coke or Dr. Pepper or dozens of donuts. So let's say the scenario maybe let's do donuts. Each box of donuts, is that how you spell donuts? I don't know. Has 12. Each box of donuts has 12. Okay. Or there are 12 donuts in each box. And then my x value would be the number of boxes. And my y values would be my donuts. This is how I always see donuts spelled. All right. And then the middle scenario, let's go to that one. They give us the scenario. It says Ryan gets $15 each week for allowance. So let's go backwards in this. Let me switch colors, go to the screen. $15 each week. So x right here can represent the number of weeks. And then the y up here can represent the number of dollars. Okay, so in 1 week he would get $15. 2 weeks he would get double that, $30. 3 weeks tripled, $45. So there is a scenario and a graph representation. Okay, so what would be the input-output table? So if he works 0 weeks, he will get $0. If he works 1 week, he gets 15. 2 weeks was 30. 3 weeks was 45. So the rule for Ryan is to, instead of writing multiply, because my pen's so big, I'm just going to put x for times, times by 15. Okay, I guess I could have wrote times. So what's my equation? Y is going to equal 15x. So we have a table, we have an equation, we have a graph, and we have a scenario. Okay, our third one, let's see, we don't have a table, equation, they give us the graph. Okay, the easy thing here is to take the information from the graph and let's put it in the table. So let me get a pretty color. Let's use, oh, I've already used that one. Let's use this purpley blue. Okay, so for every one of these, I need a pen please. One of these, I get a half. 2, I get a whole. 3, I get 1 and 1/2. So let's transfer that information up here. So with 0, I had nothing. 1, I had a half, or you could use a 0.5. 2 was 1 whole, and 3 was 1 and 1/2. So what is happening to get from the x values to the y values? Looks like I'm taking them all and I am cutting them in half. A way to say cutting in half is to say divide by 2. And my equation can look like a couple of different ways, so please write both of them down. One of them would be to take y equals, and then whatever the x is, divided by 2. Oops, look more like a 2. There we go, a little fancier. Or what they also might use is a fraction like this. Y, all the y's are equal to 1/2 of the x's, 1/2 times x. I like the first one. I think it looks neater, a little more cleaner, but the second one you might also see as well. So divide by 2 and 1/2 mean the same thing. All right, let's go see, we did the graph. Okay, now we need a scenario. I have something and someone took half. Aha! My mom took half of my money. Thanks, Mom. Boom. My mom took half my money. So, a summary of information, when we're looking at multiplicative, one thing I've noticed in the tables, let's go here, is that I need a marker. There we go. I get 0, oh, it's not going to let me highlight. Oh, I need the pen. I get 0, 0, really. I guess it doesn't like highlighter. Okay, I'll go back to my pen. Yellow, please. Okay, I get 0, 0 in all the tables. 0, 0. Then, as I go down into the graph, or the equation even, if you notice, the number and the x are right by each other. Even 1/2 x, or x over 2, they're right by each other. They're not separated with a plus or a minus. Then in the graph, if I were to draw a line, oops, a bad line, a line through all of the points, boom, they all go through 0, 0. So in conclusion, let's go down here, summary of information. Let's see what color. Let's go pretty purple. Multiplicative, multiplicative goes through 0, 0, also known as what? The origin. Smile. Okay, I'm going to pause this video, and part 2 will be the additive relationships. Hasta la vista.